Brown dwarfs are the objects which lie right in the middle of the stars and planets. But there's nothing brown about them. They're more like magenta or red. But we already have red dwarfs, which are the stars. Now stars are these big massive bodies like the sun which emit their own light and their own radiation, and the planets on the other hand are the smaller bodies like the one we live on, which do not emit their own light but rather reflect the light of some other star. The brown dwarfs just lie right in the middle of these two. They are not the stars and they are not the planets. Now usually by knowing the mass of the object we can tell in which kind of category it's going to lie in. If it's too massive, it's probably a star, and if it has a very low mass, it's probably a planet. Now the brown dwarfs have a mass range of about 13 to 80 times the mass of Jupiter, the most massive planet we have. But to understand it more deeply, we need to go back in time to see how these things evolved in the first place, so they have such stark differences. Now this is the time when there is a big and massive cloud of dust and gas. The cloud is living peacefully and calmly, enjoying its life. And then there is an explosion. A supernova explosion which would send a shock wave to the star and then disturbing it. Now, so due to this explosion and disturbance, the cloud would lose its uniformity, and due to that there would be areas with higher mass densities and then there would be the ones with lower mass densities. So what happens is, due to the gravitational attraction between the objects, the area with the higher mass density would actually started to come together. The particles were starting to come closer to each other because they would all start attracting each other. So just kind of like a chain reaction, the more matter would actually clump together, the more gravitational pull it has to attract more of the nearby objects, and thus it will keep on doing that, and it would get it hotter and hotter, and thus more pressure would build up. Now this would happen till it would reach a point where it would started fusing elements inside it. So soon the star would actually reach the critical mass and it would start to fuse deuterium with the regular hydrogen. Now this is the point where the fusion begins. We can describe a star differently, and there would be a perfect balance between the star, which is the outward pushing force which is caused by the fusion reactions in the core, to the inward pushing force which is its own self-gravity. The gravity actually wants to crush the star inside, and then the force of fusion actually just pushes it outward. So there is a perfect balance right in that. So after all this, we are left with a single major accretion disk with a hydrogen fusing star at the center. Now this accretion disk is going to give rise to the things which we have here, the planets. Now from this leftover disk we are going to see different regions where again there would be places where the masses just start to accumulate together, and as these masses accumulate we are actually going to see the small protoplanets. Now these protoplanets would soon reach an equilibrium point and then settle into a stable orbit. Now this is a time when it will actually start forming the real planets as we see today in our solar system. This is because once it settles into a stable orbit, it's going to keep on accumulating the things which are nearby it and then keep on forming more massive and more stable planet. However, the most prominent difference between the stars and the planets that we can see here is that planets don't reach enough mass that it would start fusing the things in its core. So it just stays like that, and that's what we have in a planet, which is very low mass, no radiation emission by its own. The brown dwarfs here come into the picture, which are enough massive bodies which are able to accumulate enough mass, but not enough to start the fusion reaction further. A basic brown dwarf would actually fuse deuterium in its core for the first few years, but then it settles down because after all the fusion has been completed, it doesn't have any further contraction or mass to fuse hydrogen further, just like a star. So this is when a brown dwarf settles into an orbit, and it's right there in the middle of a star and a planet. They just cannot contract further and fuse more of the elements because their cores are dense enough to hold themselves up with the electron degeneracy pressure. Now brown dwarfs above 60 Jupiter masses might fuse hydrogen in its core. But soon the dwarf would stabilize and the fusion would stop. The brown dwarf would be left like that all day. In 1995, astronomers were able to detect a few nearby brown dwarfs, and they were a part of the binary star system. Now, if you want to plot the brown dwarfs on the HI diagram, you can still do that. Though they are not technically stars, you can find them on the HI diagram at the bottom right corner, right here. It is a part which is the red color, and it is low in luminosity, low in mass, and what else? Low in brightness. So that's it guys for this one, and I hope you guys enjoyed the video. If you do like this video, don't forget to hit the subscribe button, and till then, happy stargazing. I'll see you later. Bye.